Good evening, students. Continues of the previous lecture series on a classification of signals and systems. Here we are going to discuss about periodic and non-periodic or aperiodic signals. We have understood the mathematical equation so as to decide whether the given signal is periodic or not. That is x of t is equal to x of t plus t, whereas the capital T represents the fundamental time period. So let us understand how we are going to check whether the given signal is a periodic or a non-periodic signal. See, look into the problem. Determine whether the following signals are periodic. The first one is x of n is equal to sine 3n. Can anyone say what kind of signal this is? Either is this a continuous time signal or a discrete time signal? Yeah. Since the representation is with letter n, we can easily identify the given signal is a discrete time signal. So, if a given signal is discrete time signal, the condition for the periodicity is different. So, let us see how we can solve this. X of n is equal to sine 3n. It is given in the question. So, the above equation is x of n is equal to sine 3n. So we can represent this sine 3n is equal to sine omega n, whereas omega is equal to 2 pi f. So we have to equate the 2 pi f and 3n on both the sides. Therefore, f is equal to 3 by 2 pi, which is nothing but 1 by n. X of n is always represented as sine 2 pi fn, whereas the coefficient of n is nothing but 2 pi f, and which is equal to 3 here. But 2 pi fn is equal to 3n, nn gets cancelled. Therefore, f is equal to 3 by 2 pi, which can be represented as k by n, where here k by n is equal to 3 by 2 pi. This is not the ratio of two integers. Why? Because in any expression f is equal to k by n, if any of the representation contains irrational number pi, then it cannot be the integer value. Therefore, the given signal is non-periodic. Any signal can be decided to be periodic if the integer, if the final expression contains integers. If there is any irrational number, then it can be easily concluded as non-periodic signal. This is a simple example. Let us discuss about the second example. X of n is equal to cos square 2 pi f. Okay. X of t is equal to cos square 2 pi t. This is a continuous time signal, right? X of t. T represents a continuous time signal. So, since this is a cosine function, cos square t, we cannot simply apply the condition for periodicity formula. X of t is equal to x of t plus t. Before that, we have to expand this equation. Cos square theta is equal to 1 plus cos 2 theta by 2. This is the mathematical formula. So 1 plus cos theta is equal to 2 pi t. Cos 2 theta will be cos 4 pi t by 2. We can see here the formula is also given for your reference. Cos square theta is equal to 1 plus cos theta by 2. 1 plus cos 2 theta by 2, or which is equal to 1 by 2 plus cos 2 theta by 2. So here this 1 by 2 is a constant value, or 0.5 is a constant value, This is not any trigonometric function or any variable signal, right? This 0.5 is a constant value, means this 1 by 2 is a shift added to the cosine signal, half for cos 4 pi t. But we know a cosine signal is nothing but the shifted sine wave, right? So here this is a DC shift added to the signal, and we all know any sine signal or cosine signal is a periodic in nature. Therefore, the given signal is periodic provided it is a shifted cosine signal, right? And also we can verify the signal using mathematical equation, right? So here the coefficient of t is omega. Likewise, the coefficient of n is omega in a discrete time. Here the coefficient of t is omega in continuous time. Therefore, 2 pi ft is equal to 4 pi t, and t gets cancelled, and pi also gets cancelled. Therefore, f is equal to 2. Hence, the time period is equal to 1 by f. Therefore, it is 1 by 2. Fundamental time period was 1 by 2 in the previous problem. The next is x of n is equal to cos n pi by 2 minus sin n pi by 8 plus 3 cos n pi by 4 minus pi by 3. So compare the above equation with the regular formula. X of n is equal to cos, this is the first function, 2 pi f1n plus sine 2 pi f2n plus 3 cos f2n plus theta. Since the last function is given with the phase shift, it is represented with the help of a theta. So this is complete x of n. And we have to equate every term with the standard function 2 pi f1 of n, 2 pi f2n, 2 pi f3n. So 2 pi f1n is equal to n pi by 2. From that we can obtain f1 is equal to 1 by 4. Since this is a fraction, we can determine the k value and n value here. Where n is the fundamental time period, therefore n1 is equal to 4. Since here we have 3 terms together, we have to name the fundamental time period as n1, n2 and n3. If there is only one term, no need to name it. So next is 2 pi f2n, which is equal to n pi by 8. Again f2 is equal to, cancel the pi there, n also, it will be 1 by 8 into 2. Therefore, f2 is equal to 1 by 16, which is equal to k2 by n2. Here n2 is equal to 16. Similarly, n3, 2 pi f3n is equal to n pi by 4. And again here f3 is equal to 1 by 8 and n3 is equal to 8. So these are the 3 fundamental time period, n1, n2 and n3 in discrete signal. We can't write the 3 values as the answer. We have to conclude with the single fundamental time period. But we have observed n1, n2 and n3 here. Therefore, we have to find the ratio n1 by n2, which is equal to 4 by 16. Or one simplification, we can get 1 by 4, and n2 by n3, it is 16 by 8, which is equal to 2. So both the values are rational, that is the ratio of n1 by n2 and also n2 by 3 are rational number. Therefore, the given signal is periodic. And further simplification, we can obtain the fundamental time period to be 16. Right? So the next problem is x of t is equal to cos t minus sine square root 2t. Here also we have two terms. So we can expand as x of t is equal to cos 2 pi f1 of t plus sine 2 pi f2t. Therefore, equating those with the actual problem given, 2 pi f1 of t is equal to uh, t or 1. So the coefficient of t is 1. Therefore, f1 is equal to 1 by 2 pi, which is equal to 1 by f. Therefore, t1 is equal to 2 pi. And similarly for the second term, 2 pi f2 is equal to square root of 2t. dt gets cancelled and f2 will be square root of 2 divided by 2 pi. Therefore, the remaining term will be 1 by t2. Therefore, t2 is equal to 2 pi by root 2, which is equal to root 2 pi. The ratio of the two periods t1 by t2, which is equal to 2 pi divided by root 2 pi, is equal to root 2. We can expand 2 into factors of square root. So root 2 into root 2. One root 2 gets cancelled from the denominator and the remaining 2 lies in the numerator. Therefore, the final answer is root 2. Since the ratio of t1 by t2 is not a rational number, or it is not a whole number, then the given signal is periodic. I simply try to remember, like, if the numerical answer what we get is the multiples of pi or in terms of square root, then you can simply refer it as a non-periodic signal, right? Okay. See, here's students, note down this problem. Determine the periodicity of the following signal. If periodic, determine the following fundamental time period. X of t is equal to cos 10 pi t and plus sine pi t. And another problem is x of t is equal to 5 plus t square. Um, let this be as an assignment for you. You try to solve these two problems. We'll discuss the answers in the next class. Take down the answer. This will be useful for you to verify whether what you get is correct or not. The answer for the first problem is periodic and the second problem is non-periodic. You calculate the fundamental time period. From the fundamental time period itself, you can conclude whether the given signal is periodic or not. Hope you understood this session. Thank you very much.